evaluate the integral x squared ln of 2x dx. So you know it is not easy to integrate ln of 2x, so you make that u, okay? So for you to make it u, you rearrange it. So you have ln of 2x x squared dx, isn't it? So you let ln of 2x to be u and x squared dx to be dv. To be ln of x, so that we are just audible. What do you have here? Du over dx is equals to 1 over 2x, then you differentiate the inner function. If you differentiate 2x, you get 2. So in the end, you get 2 divided by 2, you just remain with 1 over, isn't it? So you just have du to be, you take dx the other side. So you just have du to be dx over x. Multiplying both sides by dx, you get dx over x, isn't it? Then move to dv. dv is x squared dx. So you introduce the integral on both sides, isn't it?
Yes.
If you introduce the integral on both sides, you get v to be. If you integrate x squared, you get x cubed over 3, which is the same as a third x cubed, isn't it?
Yes.
Are we together? Integrating x squared, you simply add 1 to the power and you divide with the resultant power. Then come back. When you have integral of u dv by integration by parts, you are supposed to get uv minus vd du. So start substituting. What is u dv? u dv is the original problem, isn't it?
Yes.
The original problem, which is x squared ln of 2x dx, which we arranged in that order, isn't it? To give us uv, multiply u by v, u times v is a third x cubed ln of 2x. So if you multiply this by this, you get a third x cubed ln of 2x, isn't it? Then it is minus v du. So what is v du? This is v, this is du. So du, you can see du is 1 over x and v 1 over x dx, isn't it? Of course, it is du is what? v du is dx over x. Dx over x. Then v is a third x cubed. So if you multiply this, what do you get? 1x goes here, you remain with x squared, isn't it? So it is like you have a third x squared dx, isn't it? So here we have minus into plus is going to be minus. Then you put a third outside, isn't it? Then we have x squared dx. Are we together there? So that is v du. V a third x cubed du is dx over x. If you multiply, you get a third x squared. Negative. Then you bracket what you want to integrate, isn't it? What do we want to integrate? Integral of x squared d.
Yes.
So that is no longer product of two functions. You use that how to integrate a polynomial function, isn't it?
Yes.
So it is minus a third into, how do you integrate a polynomial? You add 1 to the power, you divide by the resultant power, isn't it? So if you add 1 there, you get x cubed over 3. Then at the end of integration, arbitrary integration constant. Remember, it is still inside the bracket. When you open the bracket is when what is outside affects, isn't it? So if you open that bracket, you get a third x cubed ln of 2x minus a third divided by 3 is minus 1 over 9 x cubed plus c. And you've solved that given problem. Are we together?